Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the previous sessions, we were talking about the test of significance, and in particular, we were talking about chi-square test. Chi-square test has been used for testing single variance, and chi-square test is also used for testing goodness of fit and test of independence. We have worked out some problems in chi-square test for independence for a 2x2 contingency table. In this session, in continuance with the chi-square test, we will be working out a problem in chi-square test for independence for a 3x3 contingency table, and then a discussion about critical region and power of the test is also done. This is one of the terminologies which is being used for a test of significance. This example goes like: a credit rating agency conducted a survey of customers and analyzes them by occupation and credit risk. The results were as follows. Credit rating is high, average, poor based on their skills, administrative and clerical skills of the customers, and skilled manual and semi-skilled and unskilled customers. So, the credit rating is very high who are having administrative and clerical skills are 60 in number, and very average in administrative and clerical skills are 30 and poor is 10. Like that, this tabular column has been given to you, which is a 3x3, 3 in the sense high, average, poor, 3 rows, and 3 columns in the sense administrative and clerical, skilled manual and semi-skilled and unskilled customers. So, this is a 3x3. Do not judge the number of rows and columns by including the total rows and columns. You should take only the original information. Total is not included as one of the rows. So, it is a 3x3 table, and you are asked to test whether there is any association between occupation and credit rating. So, we shall start with the step 1. Step 1 says H naught such that summation OI is equal to summation EI, which says credit rating and skills are independent. Step 2 is H1 such that summation OI is not equal to summation EI, which says that credit rating and the skills are not independent. Okay. And step 3 is level of significance. Let us have it as 1% for a change, and degrees of freedom is R minus 1 into C minus 1. Number of rows is 3 here, and number of columns is again 3, because it is a 3x3 contingency table. So, 3 minus 1 into 3 minus 1, 2 into 2, 4. Next step 4 is calculation of EI. You have to do it carefully for a 3x3 table. So, 3 rows and 3 columns has to be formed. This is EI table. Now, just look at the row totals. 120 into 100 divided by 240, isn't it? 120 into 100 by 240, which is 50. Similarly, for this cell it is 40, and this is 30, 25, 20, 15, 25, 20 and 15. Okay. So, just check the total. Total comes to be equal to same 120, 60, again 60 here. So, 100, 80, 60, which is 240. Now, listing out these values in the tabular column, This is the OI values given in the question and the corresponding EI values which you have calculated. So, OI minus EI is calculated, then OI minus EI whole square is calculated, then OI minus EI the whole square divided by EI is then calculated. Okay. The summation OI is equal to summation EI, and the total of summation OI minus EI whole square divided by EI gives you 76.166. So, that is the calculated value now. Step 5, calculated chi-square at 1% level of significance and 4 degrees of freedom is 76.166, and then tabulated chi-square at 1% comma 4 degrees of freedom. Just look at the tables. This is the 4 degrees of freedom, and 0.01 value is here 13.277, isn't it? This is the tabulated value at 1%, 0.01 and 4 degrees of freedom, 13.277. Now, calculated value is much higher than tabulated value, therefore, H naught is rejected. Calculated chi-square is greater than tabulated chi-square. So, H naught is rejected. In the sense, the conclusion is credit rating and skillness of the customers are not independent, because H naught is rejected, in the sense H1 is accepted, and this is the H1 statement. We have discussed various tests of significance. We have discussed test of significance with respect to large sample and test of significance with respect to small sample. A small tree diagram is done for summarizing all the tests of significance we have studied so far. What is that? First of all, when your case is given to you, you must identify what is the size of the sample. That is, when n is greater than 30, it becomes a large sample, and when n is less than or equal to 30, it is called as a small sample. And what are the tests of significance we have seen in large sample is, we have seen mean test, we have seen standard deviation test, and then we have seen proportion test, isn't it? Mean test, in the sense we have seen single mean, in the sense one sample and one population has been given, and difference of mean we have seen, in the sense two samples and two different populations. Standard deviation test, similarly single standard deviation and difference of standard deviation. In the same case, single in the sense one sample, one population, and difference of standard deviations, two samples and two population. Similarly, single proportion test we have seen, and difference of proportion we have seen. Just see all the formulas. In large sample is generally called as Z test, whether it is mean test or ST test or proportion test, it is only called as Z test. In small sample also we have seen mean test, we have seen variance test, and we have seen frequency test. In mean test we have seen single mean, and then difference of mean, also paired observations. Paired observation in the sense two samples are taken from two different types of samples, that is one kind of sample before treatment and another kind of sample after treatment. So, single mean in the sense one sample, one population, difference of means in the sense two samples and two different populations. Similarly, here variance test we have seen with the single variance and difference of variance, and in frequency test we have seen a goodness of fit independence test. Unlike in large sample where all the tests are called Z test, in a small sample mean test will be called as a T test, and difference of variance it was called as a F test, and testing a single variance was called as chi-square test, and a frequency test was called as a chi-square test for goodness of fit and independence of attributes. Now, this is what is the basic test of significance. We have worked out various problems in these subdivisions. Now, after discussing all these test of significance, two more terminologies are to be discussed, that is critical region and power of test. In continuance with the terminologies already discussed, null hypothesis, alternative hypothesis, and then type 1 error, type 2 error, etc. Okay. So, after working out all the problems in the test of significance, two more terminologies we shall study. What is that? Critical region and then power of the test. First of all, critical region. Studying critical region, we need to know the value called p value of a test. What is the p value of a test? P value stands for probability value of a test, is the probability that a value of the test statistic in the direction of the alternative hypothesis, and it is as extreme as the one that actually did occur, would have occurred if H naught is true. That is, a p value is ultimately nothing but a probability value of the test statistic where the alternative hypothesis is concerned. Then critical region. All values of the test statistic in the direction of the alternative hypothesis with a p value less than or equal to the significance level alpha define a set called critical region of the test statistic. Critical region is also called as rejection region. So, now let us see how the critical regions are calculated using the various levels of significance. By the definition, level alpha is the probability that the test statistic will lie in the critical region. Now, we shall see this example how the critical regions are determined for one-sided and two-sided alternative hypotheses for a given level of significance. Level of significance given is 0.05. Now, suppose the test statistic assuming H naught mu is equal to mu naught is true, that is the null hypothesis is true. The test statistic is the standard normal random variable z, and the level of significance is alpha is equal to 0.05. What are the critical regions for one-sided and two-sided alternatives? Now, we shall do this or identify the critical region using the standard normal distribution curve. First, you draw the diagram, and for one-sided alternative, first you shall do one-sided alternative hypothesis. Draw the normal distribution curve, and this area is 0.05, that is the alpha 5% level of significance. Using the properties of normal distribution curve, the whole half stands for 0.5, that is 50%. So, this remaining here it is 45% because 5% is shaded, and this is going to be 45%, 0.45, and this is already this particular left z score is 0.5. Unshaded area is 0.95 and shaded area is 0.05. Okay. So, we have to determine this z value. Just look at the standard normal distribution curve and then decide. Now, the area is given. We have to look at where 0.95 is coming in the, because 0.95 is the area, and corresponding to 0.95 you have to spot out the z value. 0.95, where I am just marking it here, this is 0.9505 and it is corresponding to the value 1.6 and 0.05. Therefore, it is 1.65. Now, this is plus 1.65. This is a one side alternative. Similarly, if you take the left z, because of the symmetricity, here it is minus 1.65. This area is 0.05 and this is 0.45. This is 0.5. So, what do we say that when z is greater than, that is we write here it as p of z is greater than or equal to 1.65, the probability value is 0.05. Similarly, when z is less than or equal to minus 1.65, the area is 0.05. Now, this is your alpha, right? Alpha is the level of significance. This is the particular z value, test statistic value. Okay. How do we write the critical region? For one-sided alternative HA, sometimes alternative hypothesis instead of H1, HA is also represented. Mu is less than or equal to mu naught, then the critical region is all values z less than or equal to minus 1.65. Since you are having probability of z less than or equal to minus 1.65 is equal to 0.05. Similarly, when HA is such that mu is greater than mu naught, then the critical region is all values z greater than or equal to 1.65. Since you are having p of z greater than or equal to 1.65 is equal to 0.05. This is in the case of one-sided alternative. What about a two-sided alternative? Draw the diagram. Two-sided alternative, the shaded area totally is 0.05. The shaded area is totally 0.05, and since it is equally distributed, we have to take 0.05 divided by 2. So that this is 0.025 and this is also 0.025. So, these are the z is equal to 0. Now, you have to check the value in the tabular column corresponding to 0.025 here, because the tabular column gives you the value to the left of z score. Let me draw only one side just for finding out only. It is not 0.025. When this is 0.025, the remaining here is 0.975, isn't it? The whole value here. This is some 0.475. This is 0.5. So, the total is 0.975. Just look at the standard normal values and where does 0.975 comes. Just look at this, the value 0.975. This is 0.975. It is corresponding to 1.9 and then 6. So, z value is here 1.96, because this is 1.96 from the tabular column, and here it is minus 1.96. Now, actually I have drawn this diagram only for spotting out z value. Okay. Actual diagram is 0.025 on both sides. So, z is greater than or equal to 1.96 and less than or equal to 1.96, the total value is 0.05. So, p of, we write it as p of z less than or equal to minus 1.96 plus p of z greater than or equal to 1.96 is equal to 0.025 plus 0.025 is equal to 0.05. That is what is your alpha value, right? For two-sided alternative, we write the critical region is a two-sided alternative HA, mu not equal to mu naught, critical region is all values z less than or equal to minus 1.96 and z greater than or equal to 1.96. Since you are having p of z less than or equal to minus 1.96 plus p of z greater than or equal to 1.96 is equal to 0.05. So, this is the critical region corresponding to the two-sided alternative. After discussing the problem of determining the critical region for 0.05, as discussed earlier, there are two levels of significance which are frequently used, that is, one is 5% and another one is 1%. Let us see for this problem how the critical region is determined for level of significance as 1%. As discussing earlier, just draw the diagram for one-sided alternative. Draw z, you have to find out this is 0.01. When this is 0.01, this is 0.49. You have to look at the value You can refer the table and see that this is 0.5, this is 0.5. Okay, for 0.99 comes in the value of 2.33, and similarly this is minus 2.33. Okay, therefore, critical region is Z, that is for HA mu greater than mu A, critical region is Z greater than or equal to 2.33, and for HA mu less than mu A, critical region is Z less than or equal to minus 2.33. Okay, for two sided alternative just draw, this is 0.005. So, the total only is 0.1, and this corresponding Z value is 2.58. You can refer the tables, minus 2.58. Therefore, for HA mu not equal to mu naught, the critical region is region R Z less than or equal to minus 2.58 and Z greater than or equal to 2.58. Since P of Z less than or equal to minus 2.58 plus P of Z greater than or equal to 2.58 is equal to 0.01. We have determined the critical regions corresponding to the levels of significance 5% and 1%. Now, after working out a problem in chi-square test for independence for a 3 cross 3 contingency table, a discussion about the critical region for various levels of significance, in the sense frequently utilized level of significance 5% and 1% level of significance, we found out the critical regions. So, the discussion is also done for about the critical region for two levels of significance, one is 5% and 1% is done in this session. Based on the discussion in this session, the following questions may be posed. What is meant by critical region? Define p value of a test statistic. How will you relate critical region and level of significance? Thank you.